Okay, welcome back, everybody. This is going to be our AP Calculus Unit 1 practice test. This is the multiple choice portion of the practice test. So I'm going to not try to use my calculator as much as I can. Some of it's calculator, some of it's not calculator on the actual test, but I'm going to try to shy away from the actual calculator as much as I can. Okay, anywho. So number one is, what is the slope of this negative absolute value where x is equal to -3? All right, so I know that an absolute value itself looks like a v, something like that. Now, how do these manipulations affect it? Well, the x plus 2 moves it to the left 2. Okay, so it looks something like that. And then the negative on the outside makes it upside down. And then if you need verification, just kind of test a point. Like if I test when x is equal to 0, plug and chug. So x is equal to 0. That would be 0 plus 2, which is 2, absolute value of 2, which is 2, and then -2 is -2. So that kind of checks out with our idea behind what's going on here. Anywho, they say, what is the slope of that where x is equal to -3? So -3 is right here. So they want to know, what is the slope right there? And that slope is a +1. +1 should be the result right there. That's the slope. All right, next. What is the k value? So the k value is right there in the equation. What is the k value of that line perpendicular to that second equation? Okay, so our number one goal is to figure out, well, what the heck is the slope of this second equation? So just doing this, we see that currently the slope is 1/2. That implies that the perpendicular slope is -2. Okay, the opposite reciprocal. All right, so we need the slope of our mysterious equation. We need that slope to be equal to -2. All right, so currently we have 6x plus ky minus 5 is equal to 0. Ky. So ky is equal to -6x plus 5. Y is equal to -6 over k plus 5 over k. Okay, so I see that the slope of my mysterious equation is -6 over k. So I need, change colors one more time, I need this -6 over k, the slope of my mysterious line, to be equal to -2. So cross multiply real quick. K is equal to 3. Okay, the domain of this is, okay, so when you're looking at the domain, what you're really trying to look for is illegal mathematics. Illegal mathematics would include bottom zeros, square roots of negatives, those sort of things. Those sort of things can't exist. All right, so one of the things that I see that could exist in this current equation is we could get a bottom 0. Okay, so that implies that x squared minus 2x, anytime that that is equal to 0, that's not okay. So we're going to figure out those. So I can GCF out at x. I see that that would be 0 and +2. So x cannot be equal to 0, nor can it be equal to +2. But that's not the only illegal mathematics that could exist in this formula. What I could also have a square root of a negative number. All right, so anytime that I get a square root of a negative, it's not okay. So that implies that means this x plus 3 has to be bigger than or equal to 0. It must be. Otherwise, it's not okay. So in that situation, x has to be greater than or equal to -3. Okay, I did a multiply or divide by a negative number, so no alligator change. So the complete domain of this is x has to be greater than or equal to -3. Also, x cannot be equal to 0, nor can it be equal to 2. So that would be option D right there. Symmetric to the y-axis. Symmetric to the y-axis, if you recall that this is an even function. So anything that is even. So A is even. Again, what I'm looking at is the exponents of the x's. So I have a 4 and a 0. So that's even. This ultimately would become what, x squared plus 4x plus 4 with a 3. So here I have exponents of 2, 1, and none. Because it's both even and odd, it's none of the above. Here I have a 3 and a 0. That's not even. And this one is just kind of strange. I would probably have to graph it to get a good understanding. But I already found my answer with A, so I'm just going to kind of run with it. Number 5. I need to know what the heck is f g of x. So f is the big equation, and any x's that I see in that equation, I replace with g. But the thing is I don't see any x's. You know, if f of x was equal to something like 3x squared plus x or something like that, then I would have to say 3 blah 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 squared plus blah 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 blah, whatever the g of x is. But it's not like that. It's just straight up 3. So replace all the x's with x to the third plus x squared minus 3x plus 6. Okay, did that? Okay, the answer is 3. There is no all right, so number 6 is the beast. All right. So spoke too soon. So here we go. G of f of x. So G is the big equation. So that's the G. And inside G, I put f. So f has to go in for every single one of these x's in the equation. So f is the number 3. So this one isn't that bad. All right, so that is the math problem right there. So this is what, 27 plus 9 minus 9 plus 6. So this is what, 33. So that was answer C. Hoorah. Moving on. Which of the functions is not odd? Okay, odd. So cosine. Cosine starts at the top, ends at the top. So this is a cosine. That is not odd. That is even, because I can split it at this. So this is an even right here. So A again, but just kind of showing that the others are odd. Let me just kind of briefly run this through. This is an x to the third. That's odd. A sine. A sine starts in the middle and ends in the middle. So it looks something like that. That implies like this. So again, an odd is symmetrical about the origin. That means the upper right is the same as the lower left. Kind of concept. And last but not least, we have third root, which is sideways disco. Again, you'll notice that the upper right is the same thing as the lower left. So that is indeed odd. So the only one that is not odd, again, is that option A. If f of x plus 2 is equal to x squared, blah, 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 then what is f of 5? Okay, so if f of x plus 2 is equal to yada, 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 what is f of 5? This is the first thing that you need to figure out. What the heck is actually x? So I know that x plus 2 is going to be equal to 5, thus that implies that x is equal to 3. That's truly what the question is. So now that I know that x is equal to 3, now I can go ahead and plug and chug into that f of x plus 2. Because if I now make that f of x, x being 3, plus 2, that is in essence figuring out what the heck f of 5 is. So that would make our x's 3. Did I make a mistake? I must have made a mistake. 9 plus 15 plus 6. 9 plus 15. Wah, wah. Good job, Ashton. Almost. There it is. My old 3 squared equaling 6. All right. Okay, number 9. The equation of a circle with radius, yada, yada, yada. Again, the equation of a circle is x squared plus, excuse me. I'm going to write it like this. X squared plus y squared is equal to r squared. All right, so there's a couple different things that we need to make this happen. Don't forget how you manipulate things. So I noticed that with the center being at negative 1, 5, that means it has to go left 1 and up 5. So when I do this, and how you report manipulations is if it's with the letter, it does the opposite of what you would think. So because I have to go left 1, that means it's a plus 1 with the x. Because I have to go up 5, that means it would be a minus 5 in with the y. And then the radius, again, is the square root of 15. Okay, so just taking a look to see if they have this reported. This one is close. Option B is close, but it's not correct. The pluses and the minuses are incorrect. So it's not option B. And it's not option C neither, because the answer, the radius squared would have to be straight up 15. Square root of 15 squared is 15. So that's neither of those are correct. So the answer is A or D. All we have to do is just do math to figure out which one is right. So we kind of have to expand these things. So x plus 1 squared. Sorry. There it is. Okay, that's the expansion. Now just reorder it so you have x squareds, y squareds, x's, y's, and numbers. So that would imply that this is an x squared plus a y squared. The x's are 2 x's. There are negative 10 y's, and the numbers are 1, 25, and a negative 15. So that would be, what, 11? Positive 11. So it's option A. There's a difference with the 2x. And then, and the 10y, I guess. So yeah, there is the difference right there. Option A is your correct answer. The values of the graph of blah, 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 and yada, yada, yada intersect are. Okay, I just got to think of this real quick. The first one, this y squared x plus 6, looks like this. And then a 3x looks like an expanded by 3, something like that. that's how you do it. However, you notice how both of them are technically equal to y squared. So x plus 6 is equal to y squared, and so is 3x. So if they're both equal to y squared, that means they're equal to each other. And so with that, what I see is 2x is equal to 6, x is equal to 3. Okay. So both of these coordinates would technically have a x value of 3. Different y values, but same x value. All right, which of the following graph is symmetric to the origin? That implies that it's, again, odd. That implies that upper left is same as lower right. And this is a 5 and a 3. This is odd. This is a 4. This is not an odd. This is a, oh, Christ, I think there's supposed to be an equal sign right there. This is an x to the third plus something x squared plus an x plus a 27, some version of that. That's not a pure odd because of the x squared that is there, and then x squared again, bam, bam. Those aren't it. A is the correct answer. Okay, moving forward, solution to this. What I think about this when I do this problem is I truly think about what the graph looks like. So this is a right 3, and it's a V. And then I'm trying to see where is this less than 2. So what I'm going to see is that it will be an actual definite interval. It's not like an interval that it'd be like negative infinity to negative 1, union 3 to infinity. Okay, it's not going to be something that looks like that. It's going to be a solid, for sure, interval. All right, so what I'm going to do is I'm going to find my important numbers. All right, so important numbers exist at 1 and 5. And then from there, what I do is I pay attention to my picture, so I know that it's between 1 and 5. Okay, I know that. Or you can just test out a point. Like, test a point, like, somewhere in between 1 and 5, like point 2. Is 2 a valid answer? And so putting in 2 into your equation, 2 minus 3 is negative 1. Absolute value of negative 1 is 1. 1 is, so this is a good value. And so what I'm seeing is this indeed is the actual value. It's not like the value of negative infinity to negative, excuse me, as you were, negative infinity to 1. To infinity. That's what I'm really testing it on, is which one is correct. Is the purple correct, or is the blue correct? And the purple is correct because of my test point of 2. 2 came out with a valid result. So which of these two intervals includes the number 2? It'd be this 1 to 5. Of the 6 elementary trig functions, how many are even? Okay, so we have sine, not even, cosine, which is even. Okay, that is symmetric about the y. So there's 1. There is a tangent. Yeah, it'd be like that. Which is not, that's an odd, that's a tangent. The others, I feel it's just taking an inverse of these, but let me just quickly take a look on my calculator. So let's go with a cosecant. A cosecant. Nope, that is not even. And cosecant not even. Oh, I know what they look like now. They look like these. That's a cosecant. No, a secant should be a secant should be using this hypothesis. Okay, secant should be a secant. So this is 1. Secant is 1. And then a cotangent, cotangent. Now, again, this is going to be odd. Yeah, that's odd, or yeah, odd. So that doesn't work either. So two of them. Okay, one of the roots. All we got to do is just find one of the roots. Okay, this kind of looks like a calculator problem, but whatever, I'll do it old school style. So I need to factor this. So 2 and -2 create -4. Multiples of -4 are 1, 4, 2, 2. Adding to a +3. 2x, 2x with -1 and 4. And so this is a 2x minus 1, x plus 2, and we are looking for roots, aka equal to 0. So the roots of this would be +1/2 or -2. All right. Real quickly, kiddos, let me just put this out here in the video. When I do this, I do all of this work on the side. I don't humor myself thinking that that's actually correct mathematics, because it's not actually correct mathematics. So I write it on the side, and then I write the stuff that is written in red and green in the actual mathematics. What I've had kids do in the past is this. They write down the problem, and then they do whatever back-ass a way of doing it. Like they'll say, oh, this is x squared plus 3x minus 4, or something like that. They'll do something weird like that. And no, that's not correct. That is not right mathematics. You know, step 1 is not equal to step 2. That is absolutely false. So don't write down things in a mathematical step that is wrong. Okay, don't do that. Okay, so if you need to do something like this, do it on the side. Do it in your, like, you know, your footnote, and then only write correct mathematics in line with what you're doing. Okay, so anywho, back to the actual question: which one is a root? That one is a root right there. Where's f of x equal to 5? So where is 6 over x minus 1 equal to 5? So I multiply out. So 6 is equal to 5x minus 5. What I did is I multiplied out x minus 1. Add 5. Divide by 5. 11/5. There you go. Is it asymptote of the graph? Asymptote, I don't know if we really talked about asymptotes a whole lot. What I'm going to do is I'm going to factor the top. Adding to a -1. All right, so this numerator is 2x plus 1. This denominator is x minus 1. This other part, the denominator is x minus 1. So these cancel. So what asymptotes are really, like for right now, is in essence kind of where bottoms are equal to 0. So right now, before the cancellation, it would be 0 and positive 1. But because the 1 was eliminated, this is called a removable discontinuity. It's not an asymptote. It's not an asymptote. And so these would be vertical asymptotes. So you'll have a vertical asymptote at x is equal to 0. Okay? And again, what an asymptote is one of those lines that you have to have something really special to kind of cross it. So this will kind of look, I think I got it backwards, but it'll look something like that. It won't cross the 0. We'll talk about horizontal asymptotes here in a bit. We'll have a horizontal asymptote at y is equal to 2, technically in this problem, but I don't think we've got that far. So in essence, look at bottom zeros that don't cancel. Bottom zeros that don't cancel. If f of x is equal to blah, 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 f of 1 is equal to 6, what the heck is f of 2? All right, so I'm going to plug in f of 1 into here in an attempt to figure out what the heck a is. All right, so f of 1 is going to be this, and that is equal to 6. So this is a plus 3 plus 1 is equal to 6. A is equal to 2. All right, so now what I know is f of x is equal to 2x squared plus 3x plus 1. Now the ultimate question is, what is f of 2? So now I use my updated equation and figure out f of 2. So 4, 8, 6, 1. All right, that is it, boys and girls. That is the multiple choice practice test. I will talk about the other one here a little bit later.